Let's have a second look at this class structure that we built, and let's look at the fly method specifically. Is this a good design where we have the fly method as an abstract method as a part of the bird class, given that not all birds can fly? So let's add a few other animals in this class structure and see how that might affect the thought process behind our design here. Let's specifically think about insects, and insects would fall under animals. Now, some insects can fly and other insects cannot fly. So if we implement an insect class, then we also have to have the abstract fly method there. In this case, we will get the getName method from animal, and we will have to override the eat and the breed methods. Let's say this class has its own unique method named crawl, and we'll have an abstract method named fly. Now, let's say we are considering two possible insects, and we are creating classes, one for a caterpillar and another for a ladybug. So what methods will they have? Both of them will have the getName, crawl, eat, and breed methods from insect. They can have their own unique methods, but what we are really interested in is the fly method. They have to override the fly method from the insect class because fly is an abstract method. Now let's think of something else. Let's think of a bat. As you would know, a bat is not a bird. A bat is a mammal. They actually give birth. Also, birds don't have teeth, but bats have teeth. And so the getTeethCount method also makes sense for bats. If we are to create a bat class, it should be here, and it should inherit from the mammal class. So these are the methods that the bat class will inherit from the mammal class. Let's say it has its own unique method, but now, as we mentioned before, you can create even more subclasses for these animals, right? The different types of penguins or the different types of sparrows. So let's say we are creating different types of bats. Let's say a fruit bat and maybe a flying fox. Now, the interesting thing here is that bats can also fly. So either we can have an abstract method here named fly, or maybe since all bats can fly, we might not even need this to be abstract and we'll just implement the fly method directly in the bat class. Or we can choose to keep this abstract. But in any case, if you look around this diagram right now, then this class will be abstract, and this class will be abstract as well. We have an abstract fly method here, we have another abstract fly method here, and we have another abstract fly method here. And what we're doing by making this abstract is that we are forcing all the classes that inherit from the bird class to implement their own version of fly, whether or not they need it. Penguins do not need the method fly because penguins cannot fly. In the same way, caterpillars do not need the method fly, even though caterpillars are insects and caterpillars can directly inherit from the insect class. We do not need the fly method for caterpillar. If we define this as abstract here, then all the classes that are inheriting from insect have to have their implementation of the fly method. What's the alternative? Maybe if we do not define this as abstract, and if we define the fly method directly here, then all of these classes will inherit the fly method, and they will not have to define their own implementation of fly. But in that case, insects that do not have the ability to fly will also get the fly method, and they will be able to use the fly method. In the same way, birds that cannot fly will still get the fly method if we do not define this as abstract. And if we define this as a concrete method, then all the bird classes that inherit from the main bird class will also get access to the fly method, regardless of whether or not they can fly. But on top of all of that, one of the biggest things here is that we have to define the fly abstract method 3 different times. So you see, there are a few things that are not efficient about declaring these fly methods as abstract in these different abstract classes. What would be great is if we have a fly interface. And in that interface, we will declare a fly method. This method is by default public and abstract. And in that case, what we can do is not have this at all for the bird class, for the insect class, or for this bat class. Instead, what we can do is whichever animal has the ability to fly, that animal will implement the fly interface directly. So since all bats can fly, we will have the bat class directly implement the fly interface. All birds cannot fly. For example, penguin cannot fly. In that case, we only want the sparrow class to implement the fly interface. And in a similar manner, all insects cannot fly. So in this example, caterpillars cannot fly, but ladybugs can. So ladybug will directly implement the fly interface. In that way, we will not need this fly method here for penguin because it's unnecessary. In the same way, we will not need this fly method either because this is unnecessary for caterpillar. Bat, however, will need to override the fly method because it is implementing the fly interface. So now this is a much better design where we have the ability itself in an interface, and whoever wants to implement that ability, whichever animal has that ability, implements that interface directly. So just as one example, if we are declaring ladybug as a class, the class declaration would look something like this, where ladybug is extending insect because it is inheriting from insect and it implements the fly interface. A class can extend only one other class. That means it can inherit from only one class, but it can implement as many interfaces as it needs. So if there are more interfaces, we can just put a comma here and type in the name of those interfaces here. When you look at this whole class structure, please try and think of it from a design perspective. What is a better design for creating our classes? Ultimately, these classes will help us create objects, but how we create these class structures will allow us to create more and more sophisticated objects in whatever program we create. Remember that the methods in an interface are by default public and abstract. We will now look at a coded example, but we will not implement the bat and the insect subclasses. We will just change the previous code that we had for this part of the diagram. So if we are directly implementing the fly interface and we do not have abstract methods here, then this does not remain an abstract class. In the same way, this will not be an abstract class either. And bird also will not be an abstract class. So let's look at the code.